Have you ever just looked up at a building that seems to literally pierce the clouds? It completely redefines the skyline, and honestly, our whole idea of what's possible. We're talking about skyscrapers, of course, these incredible engineering wonders that have basically become vertical cities in our modern world.
All right, so let's get right into it. To really get how we started building these massive structures, we have to jump back to the late 19th century. There was this huge, fundamental shift in construction that made the impossible, well, possible.
And the change was just dramatic. For pretty much all of history, a building's height was limited by its walls. The taller you built, the thicker the walls at the bottom had to be. I mean, take the Monadnock building in Chicago. Its walls were 6 feet thick at the base. But then came the steel's skeleton. This was a total game changer. It's an internal framework that carries all the weight, which meant the outer walls were just walls. This opened the door to the sky. It really was the perfect storm of innovation. You had the steel frame giving you the strength to go tall, but that's only half the story. The invention of the safe elevator is what made these new heights actually practical. I mean, think about it. Who's going to rent an office on the 10th floor if you have to climb 10 flights of stairs every day? So you put those two things together, and boom, you get the birth of the very first skyscraper, the home insurance building in Chicago. This newfound freedom just completely changed how buildings were designed. With the steel skeleton doing all the heavy lifting, the outside walls could suddenly be opened up. And that's how we got brilliant innovations like the Chicago window. It's this design that just flooded the inside of buildings with light and air like never before, totally changing what it felt like to be inside one of these new tall buildings.
But, as you can imagine, this new ability to build super tall came with a whole new set of massive engineering problems. All of a sudden, architects had to fight the forces of nature in a way they never, ever had to before. And that really became the million-dollar question. I mean, once you're hundreds of feet up in the air, you're in a constant fight with wind and gravity. So how do you design a building that doesn't just stand up, but also feels stable and safe for all the people inside it? So here's the wild thing about wind. It doesn't just push on a building from one side. As wind flows around a tall, skinny structure, it creates these little swirls of low pressure on the other side that actually pull on the building. It's called vortex shedding, and it can cause vibrations that, if you don't control them, can literally make people inside feel seasick. So engineers came up with this incredibly clever solution, the tuned mass damper, or TMD. Just think of it like a giant, super heavy pendulum inside the building, sometimes weighing hundreds of tons. It's specifically tuned to the building's natural sway, so when the wind pushes the building one way, the damper swings the other way, basically canceling out the movement. It's like a giant counterpunch to the wind. And maybe the most famous example of this is the absolutely stunning tuned mass damper inside the Taipei 101 tower. It's this massive 660 metric ton golden orb that's actually visible to the public. It's a beautiful piece of art, but it's also a powerful reminder of the incredible engineering it takes to keep a super tall building like that stable, even when it's facing down a typhoon. Of course, all that stability doesn't just happen at the top of the building. It starts way, way down in the ground. Smaller buildings can get away with shallow foundations, but for the immense, crushing weight of a skyscraper, you need deep foundations. We're talking about massive concrete and steel piles that are drilled sometimes hundreds of feet, all the way down to solid bedrock to anchor the whole thing. Modern skyscrapers also lean on some incredible advances in the materials themselves. High-strength concrete, for example, is an engineering marvel. By adding things like super plasticizers and steel fibers, it becomes not only unbelievably strong, but also fluid enough that you can actually pump it to staggering heights. We're talking thousands of feet into the air. Okay, so we've conquered wind, we've conquered gravity. Where do we go from here? Well, let's take a look at how today's skyscrapers are evolving into these intelligent, sustainable marvels that are really shaping the future of our cities. And it's interesting to see where the money goes. Take a look at this cost breakdown. Sure, the architecture and all the mechanical systems are a big chunk of it, but the structure itself, that essential skeleton and the foundation holding everything up, that accounts for a massive 30% of the entire project's cost. Now, looking ahead, designers are turning to one of the world's oldest building materials and totally reimagining it. And get this, the next generation of skyscrapers might just be made of wood.
And the reasons for this are actually pretty compelling. Engineered timber is a renewable resource, for one. It's also 5 times lighter than concrete, which means you don't need such massive foundations. Plus, a lot of it can be prefabricated, which makes construction on site way faster and quieter. And it means fewer trucks clogging up city streets. It's a huge win for crowded urban areas. And I know, this might sound like some far-off futuristic idea, but it's not. It's happening right now. Buildings like the Treat Tower in Norway are already proving this can be done. It's a 14-story apartment building made of cross-laminated timber, and it shows that the future of tall, wooden buildings, well, it's already here.
So, after more than 100 years of reaching higher and higher, what's the real impact of these giant structures? What kind of legacy do they leave on our world?
When it comes down to it, skyscrapers are so much more than just tall buildings. They're these powerful symbols of economic might and human progress. They've pushed technology forward in incredible ways, they've completely reshaped our cities, and they are constantly redefining the very limits of what we think is possible. You know, from those very first steel frames in Chicago to today's super tall timber structures, the story of the skyscraper is really a story about us. It's a reminder that when human ambition soars, our engineering wonders soar right along with it. And it just leaves you with this fascinating question. What challenges will inspire the next generation to build? What comes next?